mean, what are the components, software components, and how it looks like a hardware, and then sample project. Okay, so how we have to write the test cases in the dspace hill automation, so that we are going to learn. Okay, so I'm sharing my screen. Can you see my screen?
Yeah, Suresh. Yep, it's
Yeah,
visible.
okay. Okay, so this is a hardware in loop. Okay, what is a hill actually? So it's a hardware in loop, right? So probably I will share notepad. Okay, so previously you know about manual testing and automation testing, right? You already learned about automation and manual testing, right? What is manual and automation? Anybody can? Anybody can answer?
Yeah, manual testing means we have to do the manually. For automatic, we have used some tools to do the testing
Okay, so manually, how we can do that?
by approaching the software development life cycle and testing life cycle based on that requirement.
Okay, okay. So automation testing.
We have to
We have
use
to
some
use the
tools.
automation tools we have to use.
Okay, so it's not about the using the automation tools. Okay, so manual testing in the sense we'll write the test
Test
cases
cases
in
manually.
some type of format. Okay, so can you see my screen here? Notepad I'm showing.
Yes, we can able to.
Can able to see my screen, right?
Yeah, yes.
Okay. Okay. So manual testing and automation testing. So there are two types of testing. So which comes under which testing? Black box or white box?
Black box.
Okay. So what is black box? Anybody? Okay. So black box is nothing but a
Black
system
box
testing.
system testing.
Okay. So system testing. So black box is nothing but we'll do the requirement based testing. Okay, so we'll be having the ECU. So we don't know anything about the software inside, right? In black box. So in black box testing, we don't know anything about the software, how they have written and how the functioning going on, right? So only we know about the functionalities, features, right? So for example, if it is a body control module, okay, so or if it is a ADAS related, so there will be a like there will be like hello. Yeah, you can mute actually. I mean, if you are not speaking, thing you can mute so the other can listen properly. Okay, so usually, I mean, there is a body control module or ADAS anything, right? So there will be a features like adaptive lighting features and the 360 view feature and also the lane departure features kind of thing. So these are the functionalities. So what we'll do in the black box testing, system testing, so we'll give the input and we'll get the output. Okay, so the output should be as per the expected or not, that we'll check with the comparison with the actual output. Okay, so expected output is from, we'll take it from the requirement, and actual output after doing the testing, so we'll take that and we'll compare both. Okay, if the both are same, expected output and actual output, then test case is pass or fail.
Pass.
Pass.
Pass,
Pass.
right? If it is not matching,
Fail.
Fail.
then fail. Okay, so there are in black box manual testing and automation testing. So manual testing, usually what we'll do in retina, as per the
Test case.
requirement, we'll write in a excel sheet and we'll execute the test cases. Okay, then comes to the automation testing, so which we require. So automation testing, what we'll do, so there are different kinds of automation testing, right? So based upon the tools, and basically we'll use a particularly one script we'll use, right? That could be like in Canoi we can use a capel scripting, and Python scripting also will be using that. So there will be like robot frameworks and also the hill automation, we can say. Okay, so there are different kinds of automation testing. So this hill hardware in loop, right? So hardware in loop. Okay, so this is nothing but what comes under automation testing, right? Hardware in loop testing is comes under the automation testing, we call it as. Okay, so why? Okay, so automation testing, there are mainly two approaches for doing the automation testing. Okay, so basic thing is what? So writing a script for the each test case. Okay, here what I'm telling, script. Okay, so manual testing and automation testing difference is writing a script. There will write a manually in a Excel sheet. So then next, writing a test case in a predefined test format, right? So this is a mandatory, right? Understood right here? Hello.
Yes, sir.
Yeah, okay. So main thing is for automation testing, we'll use a script, any script that can be a Python script or any C hash or a VB script or anything, any script we can use. Okay, it should be in a predefined format. Okay. So what is the need for the hill setup? What is the need actually? Okay, so usually there are different kinds of testings as we discussed, right? Like acceptance testing, regression testing. Previous classes you have learnt about that, right? And there will be like a unit testing and static analysis, something kind of. Okay, so each testing is having the requirement, as we already learnt about that, right? So what is the need of hill setup? So okay, it's what it will give, what it will provide a real time common simulation framework, right? So for example, if we have a vehicle, right? So if you are driving, any issue, getting any issues, right? So it will get affected to the complete vehicle. Okay, so in vehicle, that issue is has to receive the all the signals, all the CAN signals, lin signals, ethernet signals, and hardware signals, analog, everything, digital signals, everything from the partner ECUs. Okay, partner ECU in the sense other ECU. So for example, there is a dashboard is there, right? Instrument cluster. So it will get the lamp indication, right? There will be a telltales, we call it as, right? There will be a display, will get speedometer, odometer, and something telltales like left turn indicator, right turn indicator. Okay, so those information from where it will get? From the partner ECUs. Okay, partner ECUs are nothing but it can be a BCM, ABS, okay, anti-braking system, body control module, or HVAC system, infotainment. Okay, so that signal, right? So in vehicle we'll get, so the real time, right? So same thing what we'll do here, we'll create the simulation of those ECUs, partner ECUs in the hill automation system. Okay, so let me share you that paint. Did you understand that? Okay, so this is what what we are saying, some DUT, right? DUT. Okay, so DUT nothing but, anybody? Device
Device
under
under
device under test. Okay, so DUT is nothing but a device under test. So right now what we spoke about, that is a dashboard, right? So it will be having the all the partner issue signals, right? What it will give? It will give a some display information, right? So display info it will give. So whatever the inputs it is receiving, right? Those signals, those ECU signals, everything we are going to simulate as per the real time. Okay. So now we have started the vehicle from ignition off to on, and engine is running. So how the all the ECUs, so how it will be reflecting, I mean how they are responding, what is the output outcome we are getting. Okay, so for engine ECU what will get? So there will be a engine speed is there, right? So every time it will, if we press the accelerator, so the engine speed will change, right? So accordingly all the parameters in the engine speed module ECU, it will going to change. Likewise all other ECUs will go change. Those are the real time, what we can say here, engine speed is a real time parameter, right? So real time parameter. So that what we are going to do that here, it's a real-time common simulation framework. So that is a importance of the hill automation. Understood this statement? Anybody?
Yeah, yes, Suresh.
Yeah, so this
తెలుగులో
is
కూడా
a
ఒకసారి చెప్పండి సార్.
ఏంటి తెలుగులోనా?
ఎక్స్ప్లెయిన్ చేయండి ఒక్కసారి.
ఓకే. సో ఏంటి అని అంటే ఇప్పుడు ఏంటి మనం కార్లో చూస్తాం కదా, అన్ని ఈసీయూస్ కనెక్టెడ్ అయి ఉంటాయి కదా. ఓకే. సో ఏంటి అని అంటే ఇప్పుడు డియూటీ ఉంది. డియూటీ అంటే ఏంటి? డివైస్ అండర్ టెస్ట్. సో అది ఏమి అవ్వచ్చు, ఇన్స్ట్రుమెంట్ క్లస్టర్ కానీ బీసీఎం ఏదైనా కావచ్చు. ఓకేనా. సో వెహికల్ నడుపుతున్నప్పుడు మనకి ఏం చేంజ్ అవుతాయి? యూజువల్గా మనకి తెలిసేది ఏంటిది? ఇంజన్ స్పీడ్ అనుకుందాం. వెహికల్ స్పీడ్, ఇంజన్ స్పీడ్. సో దీస్ ఆర్ ద రియల్ టైమ్ పారామీటర్స్, రైట్. వెహికల్ రన్ అవుతుంటే చేంజ్ అవుతూ ఉంటుంది కదా, రైట్. సో ఆల్ రియల్ టైమ్ పారామీటర్స్ ఏవైతే ఉంటాయో దెర్ విల్ బి లైక్ రియల్ టైమ్ పారామీటర్స్ అంటే ఇంకేం ఉండొచ్చు, రోడ్డు మీద వెళ్తుంటే మనకి ట్రాఫిక్ ఉంటుంది, స్పీడ్ బ్రేకర్స్ వస్తాయి. సో ఓకే, ఇఫ్ వి ప్రెస్ ద స్పీడ్ బ్రేక్, then the parameters will change. How come? The engine ECU speed untunda, that will go down, right? అది తగ్గిపోతుంది. దెన్ నెక్స్ట్, సో ఇలా దీస్ ఆర్ ద రియల్ టైమ్ ఆన్ రోడ్ ఏవైతే ఉంటాయో పారామీటర్స్ చేంజ్ అయ్యేవి, దోస్ ఆర్ ద రియల్ టైమ్ పారామీటర్స్. సో దాట్ వీఆర్ గోయింగ్ టు టెస్ట్ ఇన్ hill setup, hill automation setup, hardware in loop setup. Okay, so if any interview also, if they ask the question what is a hill automation, then you need to give this answer. So it is a real time common simulation framework. Okay, next. So automated testing of a predefined specifications of a complex system which enhance the testing quality. Okay, another thing what it is, one is a real time, right? Real time simulation. Next one is a testing quality. Okay, so automation testing is main thing is we will be having the specification, right? Requirement specifications, right? Complex system in the sense it can be a ADAS, right? It can be anything like connected car features, right? Nowadays it's a very popular, right, in EV vehicles and or even two wheelers and everything. Okay, it will connect it to the cloud and everything. So those things we could not test on the real time. So if you see, ADAS is there, right? So ADAS is there, there will be a lane departure functionality, there will be a like collision avoidance functionality. So those things we could not, we can test in real time, but that is not multiple times we cannot test those things, right? So for those complex system, right, so there will be a predefined specifications for the complex systems which will we can enhance the quality, testing quality. How come? So we can test using this hill automation by simulating the real time simulation. Okay, simulation inputs. So we can test multiple times, any number of times we can test, so that the test quality is improved. Understood here? Okay.
Yeah.
So then next, yeah, so provides a cost effective solution for the automotive testing complex system. Okay, so if we are using, if we want to test a real time, what we have to do usually, other than if you don't have, for example, hill automation, right? So if you want to test a real time, directly we will have the we'll take the vehicle and we'll test on road. Okay, so there are any number of issues will be there, right? 30, 40, 100 till 100. So by testing each ECU, so that is a time taking process, and also the we need to have the any, whatever the, if, for example, if 30 ECUs are there, so we need to have the 30 vehicles we need to have. Okay, so we need to drive each for each ECU we need to test, we need to take a one vehicle to test. Okay, so that is the thing, cost. Because hill automation we can test anything, all the 30 or 40 ECUs we can test. Simply device, whatever the device under test is there, right, remove that and replace any other ECU, 30 ECUs replace that, and you can test, and you can do the same thing, real time testing over there. Okay, so simply we can change the configuration of the system and then we can do the testing. Okay, common for all ECUs. Okay, so that is the cost effective and automation testing for complex system. And next thing is testing time. We already told, right? Testing time. So it will decrease the testing time. How come? So this is as we said, this is a automation testing, right? So for example, there will be what we can do. For example, in office, I mean, we need to do the some task. I mean, automation testing of particular this thing. Okay, so we have written the test cases. We'll start running the test cases. Okay, so usually there will be for ADAS features and any infotainment or anything, there will be n number of test cases. Okay, so near about 500,000 test cases also will be there. Okay, so for n number of test cases, so if you are testing it manually, what will happen? It will take time. Okay, so even if you use the capel scripting also, so it will take time to execute. Okay, so by using the hill automation tester, so what we can do that if we start one time, okay, execution, so it will continues till whatever the time it is required, whether it can be a 24 hours, 42 hours, sorry, 48 hours and 72 hours, 3 days, 4 days, 5 days, number of days it can continue, okay, with uninterrupted mechanism it has, right? So it will continue to execute all the test cases. Okay, so and we can call it as a night run. What will call it as night run? Okay, so it's a continuous day and night testing. Clear?
Sir, what is the full form of nitration?
Night run. Night, there is no full form actually. Night run. Night run in the sense continuously day and night testing. Okay,
Okay.
so night we won't be there, right? Night in the office, we our working times are what? 8 hours or 9 hours, right? So from morning to 9 to evening 6. Okay, so what we have done in this hill automation, so what I said, first we start running the hill automation. Okay, so then it will continues to run till 1 day, 2 days, 3 days, day and night. Clear? So that is nothing but a night run. We'll call it as in industry, they will call it as a night run. Okay, that means even night also nobody will be there, but it will continue to execute test cases. No manual intervention, no monitoring, no nothing. So next day, next 2 days also we can go and check. So what are the failed test cases? What are the past test cases? That's it. That is a night run. Understood?
Yes, sir, understood.
Okay, so and the safety, right? So for example, if you are testing, you might be hearing about this, right? Autonomous vehicle. So during that, what happening? Autonomous vehicle, some accidents happen, right? So without, it's a driverless car vehicle, right? Autonomous. So during that time, some accidents happen, and on road if you are testing those things, so like kind of safety also matters here. Okay, so by using the hill setup, so we can maintain the safety. And next, vehicle availability. Okay, so vehicle availability, as we already discussed, so we won't be having the vehicle, right? For everything, I mean, for all the issues to test, we won't be there won't be availability of vehicle. So that it is a very useful, hill automation is a very useful technique to do the testing of the complex systems, right? Clear up to next slide? Then next, so design steps, what we need hill automation. So as usual, for manual testing also we need input specification and test cases. Clear? So input specification is nothing but SRS, software requirement or system requirement specifications. Okay, and what else will require? SRS we know, and what else? DBC files, and what else?
CDD files.
Yeah, CDD files. Okay, or PDX files. What is the use of CDD file?
True diagnostic testing.
UDS. Yeah, okay. So PDX or CDD files are useful for the UDS. Okay. Diagnostic testing. Okay. So whatever the architecture and system pin diagram. Okay. What is this pin diagram? You might be knowing that, right? If you consider, 8051 microcontroller, there will be a pin inputs and outputs. So what are the digital inputs? What are the CAN inputs? And what are the CAN outputs? And what are the digital and analog outputs? So those are the system pin diagram. So we need to know that. Okay. So these are the inputs for what? Inputs for hill. Okay. So, and all features to be covered, right? So all features, whatever the features are there in the ECU, right? So those should be covered in this. Okay, depends on the feasibility that we'll discuss. So functional testing. Okay, what we can do, functional testing in the sense, anybody?
Testing
It's nothing
of
but, yeah, testing of the functionality.
functionality,
Okay.
not high level.
Yeah, it can be for ADAS, it can be a lane departure or the cruise control or anything. That is a functional testing. Testing those functionality is nothing but functional testing. And selection of right component for the automated hill. Okay, so what we have to do, design steps is nothing but, so right component for the automated hill. For automated hill, we need to select the right component, whether it could be a dspace. Okay, there are different vendors are there in the market. Okay, vendors are in the sense suppliers. Okay, dspace is there, vector is there, etas is there. Okay, so likewise there are multiple, even MATLAB is also providing. Okay, so these are the vendors of hill. Okay, so we need to check all these whether we have to use the dspace, etas or vector or MATLAB. So depends on our requirement, we need to go for the those vendors and we'll select the components accordingly, right? Those are the components. And next, proposal of the hill. What is the proposal? We have selected, right? So proposal means check all this, whether we have to use a dspace, etas, or vector, or matlab. So depends on our requirement. We need to go for those vendors, and we'll select the components accordingly, right? Those are the components. And next, proposal of the hill. What is the proposal? We have selected, right? So proposal means proposal means, okay, so how to test. Okay, so how to test? What are the, we have selected the component. Okay, so which hill automation setup we need to use. Okay, so whether it could be a dspace, etas, or vector, and matlab, and how to test. So based upon the requirement, so whether it could be adas or anything, so those things we need to select, and we need to do the proposal of the hill automation, right? Next, writing a software code for automated testing. Okay, so we already discussed it, nothing but scripting, whether it could be a python, c sharp, or vb, or anything. So automated testing, where we can do that? In Canoi, Capel. Okay, so dspace, what we can do? vb or python. Okay, python also we can do that. Okay, then next, procurement and integration. Okay, so what we have done, already we have selected a component, and proposal also we have given. Okay, then what will that procurement, in the sense, will purchase that component, complete dspace setup as per our requirement. Okay, that can be, what is this? Whether it could be a dspace, or etas, or vectors, or matlab. Okay, so that we'll purchase the components. I mean, we'll purchase the complete setup from them, and we'll integrate. Okay, so these are the basic steps in the designing the hill automation. Clear? Understood? Okay, so basically whatever the system we are proposing, right, we are selecting, right, so that is basically based upon which input specification. Clear? If you want to test adas, okay, so we have to select one type of hill automation. Okay, so if you want to test a bcm, body control module, we need to set a select one type of components of hill automation, right? So that will going on, we'll discuss those things. Okay, hill setup, what will have hill setup? So usually plant model. Okay, this will discuss ecu know already, electronic control unit. Okay, so next, hill test bench system. Okay, that can be, as I said, hill test bench system, that can be a vectors, or dspace, or etas, or matlab. Okay, and next, host pc. Host pc, in the sense, it could be a laptop or the desktop system. Okay, which will be work as a server, and everything, I mean, all the software will be running in host pc. Okay, so అన్ని సాఫ్ట్వేర్లు ఏమవుతాయి, ఇందులో రన్ అవుతాయి, రైట్? సో ఏం యూజ్ చేస్తాం మనం? ప్లాంట్ మోడల్. సో వాట్ ఈస్ ద ప్లాంట్ మోడల్? ఓకే, సో దేర్ ఈస్ లైక్ సిమ్యులేషన్ అని చెప్పుకున్నాం కదా మనం. We talked about simulation, real time simulation, right? So those real time simulation, where we have to develop those things? In plant model. Okay, plant model, what will do? Okay, tell me, what will do that?
Is it a bench setup?
No, it's a plant model, in the sense matlab model. Okay, so we'll develop the, what will do? Develop the real time
Pascals and
Simulation.
all.
simulation. Okay, so in what? Matlab and Simulink. Clear?
Do we use MATLAB? Do we use MATLAB?
We'll use MATLAB only for this.
Okay.
Okay, so here don't confuse. So
In
MATLAB is
Canoe
having
also we
the
can develop in Canoe simulation also we can develop, right?
no. We could not do that. Okay, so in basically in your hill automation, plant model is nothing but there will be a real-time simulation we need to develop. That will be only in the MATLAB Simulink. This is a standard.
Oh,
Sir, kindly explain regarding the plant model elaborately.
We'll go on, right? We'll elaborately discuss those things in coming slides. That's what I'm
Fine.
writing here. Okay, so what we can do that standard for all hill. Okay, so what we'll do this in this plant model, as I said, develop the real-time Simulink. So MATLAB, what will have? So we modeling tool, right? MATLAB.
yes, in MATLAB Simulink we have some components, so those are we
Yeah.
have to connect in that
Hmm.
Simulink and we have to run it. It
Okay.
will
So
generate the output.
yeah. So in detail, what is the plant model? I will explain here only. So usually, what I said for the vehicle, what will get? Ignition, input, okay, and all the CAN signals.
Hi, sir.
Okay. Hello. And
Sir, are you writing anything in Notepad?
yeah.
No, I think you're not shared that Notepad screen here.
Oh, really?
We can only see the PDF.
PDF only, sir.
Yes, sir. Since from beginning we can see only one window, sir.
I beginning only I asked everything, right?
No.
Okay.
Just you are. I thought of randomly you are speaking.
Let me share that entire screen. Okay. Can you see here?
Yeah, now it is.
Yes, sir.
Okay. You should say actually I'm writing. Okay. Before also I asked. Okay. Let's continue. So what is the plant model? I said. So which is nothing but a real-time simulation will develop in that. Okay. What is a real-time simulation? I said. Anybody? Anybody can answer?
Simulating other ECUs.
Yeah. Simulating the all vehicle partner ECUs. We can say or all the vehicle real-time parameters. Clear? Understood. That can be a CAN signals or engine speed or vehicle speed. Okay. And next ignition input and like power modes. Okay. So these are the everything inputs we need to give. We need to simulate. Where we can simulate? Hello.
In MATLAB.
MATLAB, right? So from the MATLAB, what will get? Plant model. Clear? So this is about the plant model. Understood? Hello.
Yes, sir.
Any
Yes,
doubts?
sir.
No, you can
Hello.
continue. Yeah, you
Any
can
doubts?
continue.
And
You can
hill,
continue.
Suresh, I have one doubt. Actually, hill, mill, sill, and dill also this is different, right? Hill and somewhat other three components also there, right?
Those are different test cases. I mean, test strategies. Okay.
Okay,
So those are different. So we are talking about only the hill.
hill. Okay,
Okay. So
okay.
from per hill, so we need to have the plant model that will be required for the real time simulation, and that will be developed in the MATLAB Simulink. Okay. So and what are the things we have to do in the real time simulation? What are the need we need to consider? Aim consider చేస్తాం ఇక్కడ ignition input, power modes, CAN signals, engine speed, vehicle speed. Not only these things, anything. I mean everything. Okay, all every parameter in vehicle. Okay, so all the vehicle parameters of ECUs. Okay, and whatever the real time parameters, right? So those things we'll consider in the plant model. and we'll develop those parameters in simulate in which tool? MATLAB and Simulink. Okay, that is what plant model. Okay, clear?
Yeah, fine, sir.
Yes, yeah.
Yes, sure, sure.
Okay, so then next ECU you know already, electronic control unit. Okay, next what we know, Hill test bench system. Okay, so what I said, Hill test bench system here, dspace, Hill or vector, anything we can use. MATLAB Hill or also is there, right? Anything we can use for the test bench. And host PC you know already, right? That is a desktop system where we can run our test cases. Okay, clear? You can go
Yes,
next
clear.
slide. Right here, host PC. Run all test cases. Okay. So general conceptual diagram. So this is for the hill automation, whatever we discussed, right? So what we can say, one is a host PC. Okay. Next one is a hill system, hill automation system. As we discussed, this can be a dspace or anything. Okay, any vendors. And next, this is the electronic control unit. What we'll get here? IO signals, input output signals, input signal and output signal from the ECU. So this is the plant model. What we discussed. So this is nothing but a real-time simulation. Plant model is nothing but, so real-time simulation will be putting into the hill system and will make it run. Okay, so to simulate the ECU, what it requires is ECU. Actually, hill automation is a real-time system, right? Real-time automation system, right? Okay, so all the simulated inputs where we'll get from plant model నుండి మనకు అన్ని సిగ్నల్స్ వస్తాయి దీనికి ఎలక్ట్రానిక్ కంట్రోల్ యూనిట్ కి. క్లియర్? Okay, so this is the word. Okay, so here we can see plant model. Plant model is a real-time model, runs all the time in the simulator. Okay, and creates a simulated vehicle condition for a electronic control unit which is under test. So ఇదే కదా మనం డిస్కస్ చేసుకుంది. So this is what, right? What we discussed. So what is this? Plant model is nothing but real-time model that will run in the simulator. So where will it will be there? Simulator where it will be there? In hill setup. Okay, hill automation setup. So the simulator will be there in hill automation setup. There will run plant model. Okay, so and which is under the test. ECU is nothing but a electronic control unit which is under the test. So what we are going to do, that create a simulated vehicle conditions. Can you see here? What is this? Plant model creates a simulated vehicle conditions for electronic control unit which is under test. Here, so if the question is asked like this, so what is plant model? You can answer straightly. You can answer this. It creates a simulated vehicle conditions for the electronic ECU. Okay, and plant model, all signals are in our control only. Okay, so those signals, what we can do in plant model? In control means
Under our control.
okay, so plant model we can control all the signals, right? So how we can do that? By manipulating, right? By manipulating or changing the input. Okay, so if you want, for example, engine speed should be a 500, okay, or the 1000. So those things we can manipulate and change in the plant model. Clear? And next,
Sir,
for example,
we will give only inputs as signals, huh? Means this value like that we will input, or otherwise we will send any signals, waveforms like that.
That we'll discuss in a coming slides actually. Okay, so for how we can give the inputs to the plant model.
Okay.
Okay, so for example, so for testing a BCM ECU, BCM is nothing but body control model. Our developed plant model gives a real-time signals of all ECUs like a EMS, PDC, and IC instrument cluster and RLS. Okay, so what we can say here, BCM body. If we want to test this BCM, okay, so what we have to do, develop the plant model, and which are real time, which gives the real time signals from all the ECUs. Okay, so which gives a plant model, what it will gives real time signals from all the ECUs like EMS. EMS is nothing but engine management system, PDC, parking distance control, and instrument cluster, RLS. Okay, so this kind of this is a for example I'm telling. Okay, and next, so ECU. What is this ECU? ECU is a unit which is going to be tested with a simulated environment that we know already, right? What is ECU? And next example, in case of a vehicle infotainment, infotainment is nothing but HMI, right? Where we can play the media, music play chestam manam, right? Infotainment hill. Whole infotainment system will act as a ECU. Clear? That infotainment system display is there, right, in vehicles. So that can be act as a one ECU that we know already, right? Vehicle with any manual interference required for the infotainment is environment, okay, which can be simulated by the plant model. Okay, so you know already infotainment. Infotainment, anybody know?
Yes.
You know this infotainment. This is a infotainment, right? So infotainment, what will do? Manual intervention. So if we want to access any media or navigation, or if you want to play any music, or if you want to change any controls settings, Bluetooth settings or anything, so we need to manually access. Okay, we need to press through the our hand. Okay, so touch screen, right? That is the touch screen, and we need to manually access. So what we are here, it is saying that vehicle infotainment, all infotainment will act as a ECU. That vehicle, any manual interfaces required for the infotainment is environment which can be simulated by the plant model. Understood? So in vehicle, what we are doing? Infotainment, manually we are pressing all the buttons there on touch screen, right? So those things can be simulated by plant model. Getting my point? Infotainment. Okay, so which can be simulated by the plant model, all other hardware. Okay, so now we got a clear picture, right? And next, architecture. So what it comes in architecture, hill architecture? Okay, so there will be a actual hill system consists of simulated loads, breakout box, FIU, mapping box, okay, signal condition box, simulator, and here it comes simulator. Somebody asked, right, how it gives the signals to the simulator, and power supply, UPS. Okay, that we'll see now. Okay, so this is a hill automation. Okay, so there will be a first, what we'll have as per the architecture. We are going to discuss the architecture now, right? So what we'll have first? Power supply. Okay, so power supply, what is it? So in vehicle, will be having the battery voltage. Clear? So but for doing the ECU testing, we need to have the some power supply. Clear? What is that power supply? How much is the voltage?
9 volt
15 volts.
DC.
DC will take
9
5
to
volts,
15
sir.
volts.
12
DC.
volts.
9 or 12 volt DC.
No, no, not 9 volts. Normal voltage is a 12 volts.
12 volt. Okay.
Okay. So 9 volts is a very lower. So if we are getting a 9 volts, okay,
12.5 to
in vehicle,
13.5.
in vehicle certain functionalities won't work.
Okay.
Okay. So that's what. So what we are talking about, UPS, you know, right? Uninterrupted power supply.
Yeah.
For desktop,
Yes.
we'll use, right, UPS. So backup, power
Backup.
backup.
So power
Okay.
backup.
So for hill automation, why we need UPS? Basically, it's what we can say, we need to run a 24/7 hill automation. That's why we need a uninterrupted power supply. That is one thing. And next, power supply. So this will be like, so power supply, why we need? So this is a programmable power supply. Why we need programmable power supply? Because programmable is nothing but we can vary whatever the voltage we need. Okay, why we require that voltage, variable voltage? Why we need in the to test ECU?
For changing the voltage.
Changing the voltage, right? There will be conditions. Okay, so there will be a condition like normal voltage is how much? 12 volts. Okay, so lower voltage, how much? 7
9,
volts. Okay, higher voltage.
19
Higher
volts.
voltage, how much?
15.
18 or 15 volts. Okay, depends on. So usually there will be conditions. Okay, in is for the ECU. So all the normal functionalities work at 12 voltage,
12 volt.
right? So there will be a conditions, right? We need to test these things. So at lower voltage, whether this ECU is working or not, or at higher voltage, whether the 18 volts, whether this ECU is working or not for particular functionalities. Those things we need to test. Have you heard about this? Lower voltage and higher voltage in the manual testing?
Yeah, low level
Yeah.
DTC, high level DTC.
Clear. So here what we are doing, we are changing the voltage. 12 voltage, 7 volts, 18 volts. So that's why we are using this power supply, which is a programmable power supply. We can vary by using this power supply with 12 volts or 7 or 18, depends on our requirement. Clear? Okay. Next, power supply is done. Next, simulator. Okay. So coming to this, so here we'll have the simulator. Okay. I'm writing only sim here. Okay. So we can have the simulator here. So top down, what will be having? Power supply. Okay. First one is a power supply. Next one is a simulator. Okay. Next, above that only we'll be having the simulator. So what it will do, simulator?
Gives inputs in the
Okay.
model.
So whatever the plant model is we have developed, right?
The class runs until what time?
We'll completing in 5 minutes. I think we start by late, right? Approximately 10
Yes.
minutes. So we'll
Okay.
run by next 10 minutes. That's fine.
Okay.
Okay. So we'll run the plant model in simulator. Okay. So what it consists simulator? It will be having the OS same like our PC, desktop PC. Okay. So for this simulator, usually there will be a QNX. QNX, you know QNX?
No,
Anybody?
sir.
QNX is a OS. Okay. Linux. Linux, you know? You don't know Linux?
Operating.
Yes, operating system.
Operating system, right? So likewise, QNX is also operating system. So in this simulator, it will be having the same like a simulator is the same like a
Oh, yes.
our laptop or desktop, you can say desktop, like CPU, central processing unit will be there, right? In desktop, what will have? It will have the i5 or i7 processor. Okay, it will have the processor, it will have the RAM. Okay, and it will having the hard disk also, right? Same like our desktop. So it will be having the OS and also the RAM and ROM in the sense hard
Reader.
disk,
Yeah.
hard disk. Okay, right, HDD. Okay, now it comes with the HDD also, SSD. SSD, you know, this is a hard disk. Okay, now. So then next ఏమొస్తుంది ఇంకా సిమ్యులేటర్లో? సో ఓఎస్ వచ్చింది, ర్యామ్ వచ్చింది, వాట్ ఎవర్ ద పెరిఫెరల్స్ ఏవైతే ఉంటాయో. Okay, so that will have in the simulator. It's like a CPU in our desktop system. Clear? Understood? There will run the plant model. Clear?
Sir,
Everyone?
that QNX is the graphical user interface or command line interface?
No, 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 no. This is not at all the graphical actually. This is same like a OS, like Linux. Okay, so there are different, right? Ubuntu will be there, Windows.
Yeah,
What we
yeah,
are
yeah.
using the Windows 7, Windows 10, Windows 11. Okay,
In
likewise
line,
Linux, yeah, Linux,
in,
Ubuntu, and QNX. Okay, so this is a OS actually, operating system. So what will
fine.
have simulator is having the same thing. It will have the processor. Okay, so it will have the processor. Okay, so processor we know, right, already. Intel, what we have, i3, i7. Okay,
Yeah,
i9. So these are the processors, like EMD also will be having. So same kind, there will be some customized processor will be there, and along with that there will be a RAM, and also the hard disk will be there, and also the peripherals, some communication interfaces will be there. Okay, and next Linux will be there, right? Okay, that is what. And next simulator we have done. Next mapping box. Okay, so upon this what will have? Mapping box. So what is the use of mapping box and signal conditioning? What is the use? So here we can see that. Okay, next slides we can have that load box and everything, we can discuss those things. Okay, so mapping box is a sense, it will be having the all signal conditioning. You know what is this signal conditioning?
don't know, sir.
Is it
So
regulating?
yeah, so see, what we can say. See, you know that analog ADC, you know,
Another
Yes,
digital
sir.
converter.
digital IOC, you
Converter.
know, digital IOC, you know. Okay, so on the CAN, LIN, and Ethernet. Okay, all the protocols. Okay, so what it will do, signal condition box, mapping box, it will having the all the interfaces. Like for example, if the ECU wants the ADC input, okay, so this box will give. Okay, it requires the digital input or output, so it will give, this mapping box will give that. Okay, so and next it will have the CAN, LIN, or Ethernet, any protocol, so that thing it will give. Mapping box will provide the those communication interfaces to the ECU.
It's
Okay,
work like a bridge, I guess.
yeah, yes, exactly interface, it works like a interface. So okay, definition we can see in the next slide. Okay, so that is what signal condition. Signal condition in the sense, what we can see here, we can give some input. we can give the digital input and it will be transmitted to the analog
Yes,
input. Okay, so where we can give the digital input from the MATLAB model. Okay, so we'll give just a input. So that comes the digital input, and we'll give, for example, what we can say. Yeah, mobile is there, right? We all are using the mobile. Okay, so how the GSM signals are transmitting, that 3G and 4G, those are the digital signals, right? And how we are getting the output? By voice. Okay, by microphone we can talk, and by voice, by speaker we can hear the voice. But the transmission media is between tower to mobile phone, that is the digital signals, 3G or 4G. Clear? So that is nothing but a signal conditioning. So it is changing, right, in one state to another state. So the digital signal is changing from digital signal changing to analog signal, which is the output speaker or microphone. Clear? That is a digital signal. Understood? Any doubts here? Okay, next FIU. FIU is what? So in top we'll have the FIU. Okay, so FIU is nothing but a failure insertion unit. Why we use insertion unit failure?
we create false.
Exactly. Okay, so there will, we already learnt about that, right? For some applications we'll be having the what we'll having? CAN bus of CAN protocol bus of everyone.
Yes, yes, sir.
Yes, bus
Okay.
of condition.
Yeah, how we can create that?
Manually, we can create like positive
Can
battery
canvas
positive
short.
to
Okay,
Short to ground.
short to ground. Okay, short to battery, short to ground. So we can, so bus of how we can do that? I mean, shorting the, whether it, the CAN H is there, CAN L is there, that can be shorted to the ground or the power supply. Okay, short to battery or short to ground, we can do that. Okay, so this can be anything. There will be a digital IOs, right? ADCs, digital IOs, and CAN, anything. So those failures, everything we can create in this failure insertion unit. Clear? Understood?
Yes, Suresh.
Yeah. So next, breakout box. Okay, so breakout box is what?
Load box.
Yeah, so there will be like a for example, we have some jumpers, right? Banana pins jumpers will be there, right? You know those things?
Yeah.
yes, sir.
Okay, so
You're asking about banana cable or what?
yeah, banana cable. I will show you that we have an image on that for that. Okay, breakout box in the sense it will break the signal. Okay, if you are giving some digital signal, right? So for example, ignition input we are giving. Okay, we can, what we can do, that we can open and close the circuit. So what we can do, I mean, example is nothing but if we switch on the bulb will, I mean, if you switch on the switch, normal switch in house, what will go? It will glow, light will glow, right? If you switch off, it will get off. Okay, that is nothing but if you are closing the circuit, light will glow. If you are open the circuit, light will go off.
By using
Clear?
jumpers, sir.
Yes, exactly. So breakout box is nothing but jumpers in your
Connect. Okay.
yeah. So in general terminology, we can call it as a jumpers. Okay, what is jumpers for open and close the input IOs. Okay. And next, what is this simulated loads? Simulated loads in the sense
Providing inputs.
outputs. Okay, simulated load in the sense. For example, for BCM, what will have load? Lights. Okay. So for door locking, unlocking, lock and unlock, what will have? Motors. Motors, you know. See,
DC motor.
sorry, door lock, not unlock, unlock. Screen is there, right? Glass window. So doors, car doors, glass window will be there, right? That will operated by the motors. Okay. So these are the loads actually. So for body control module, what will have? It will have the headlamps. Okay. Backlights will be there. Okay. Even in the roof lamps inside cabin also will have the lights. Okay. Then door glass window will be there, right? Glass window ఉంటుంది కదా, దాన్ని అప్ అండ్ డౌన్ చేస్తాం కదా మనం, దానికి కూడా మోటార్స్ ఉంటాయి. ఓకే. సో వాట్ వీ కెన్ సే హియర్, లైట్స్ ఆర్ మోటార్స్. Motors. Okay. Example for this motor is nothing but example door glass window. Clear? So that is those are the simulated loads we can connect. Okay. So how much is voltage required, right, for that high beam and low beam and backlights? So those loads we can connect it to the load box, and we can check, okay, whether the motor is working properly with this input, or whether the light is glowing or not. Those things we can check in the simulated loads. Clear? So this is what structure. Okay, so what we discussed here, can you repeat? Everyone, can you repeat?
Breakout box.
No. First, what
Sir,
it is?
in
Start
simulation,
with.
what you have done, sir? Only simulator only you give to input, sir, and simulator load means outputs comes, sir.
No, simulator we already discussed it, right? That is a simulated parameters. Here we discussed, right? Simulator. What will have? We will run the plant model simulator. Okay.
In plant model, we are giving to the input, sir.
Real-time
Inputs,
parameters.
input
Plant
signals are
model.
given.
No, in plant model, what will give here? We can control all the signals by manipulating and changing. What are they? Real-time parameters. Yeah, inputs and outputs, everything. It can be a CAN signal, it can be a ADC signal, it can be a input-output digital signals. So in plant model. Clear?
In plant mode also check the power supplies, sir, and low and high and medium.
Yes, exactly. So we can control the everything, whether it could be a whatever as per our requirement. If we want to test a low voltage, higher voltage, that we can do it from the trigger from the plant model.
But simulated loads are also same, sir. What is the difference between simulated and simulated load?
No, simulated loads.
Mm-hmm.
No. That, see, don't confuse here. See, what it consists simulator, it consists of OS and processor where the plant model can run. Clear? Simulated load in the sense what I said. BCM, lights will be there, right? You know
Motor
lights?
is there.
Headlamps, you know?
Yes, sir.
Headlamps, you know? Of car.
Yes, sir. No, sir.
These, you know? These are the loads, output, right? So car is having the output. Okay, these are the lights. There, likewise, there will be a door motors. For door glass is there. So to up and down, we can use the motors there. Okay. So likewise, there will be a loads which can drive. So this can be driven by which ECU? Anybody?
BCM.
Body control.
PCM, yes, exactly, correct. Okay, so body control module will drive this lights. Okay, so this light will be having the some voltage and current. Okay, so for simulated loads, what I have said, it can be a lights or motors, anything that can, whether it is, see, I'm giving the simulated input through the simulator to each ECU, and then whatever the output we are getting, whether that is going on or not. I mean, if I'm giving the high beam on, right? In simulated loads, I can check that. Okay, that high beam is on or not. Understood?
Yes, sir.
Clear?
Yes, I understood.
Okay, that is a simulated load. Okay, so can you tell again? So this is the main thing. Architecture usually they will ask questions like this only. I mean, this is the main thing. And can you tell about UPS? What is UPS?
It is a backup, sir. For a backup purpose, we use
Okay. Yeah. Then power supply. What is power supply?
it gives different voltage, sir. 12, 7, 18.
Exactly. Okay. So this is nothing but a programmable power supply. We can call it as. Okay. And next thing is a simulator. Anybody? What is simulator?
Operating system or RAM, hard disk.
Which can run the plant model. Right?
Okay.
What we said? We will run the plant model in the simulator. It's like a
Operating
CPU.
systems.
So it has everything. Operating system, processor, and everything it will have. Okay. So next thing is mapping box. So what is mapping box? Signal
EDC analog
conditioning.
to digital connect.
Interface.
Yeah, okay. So interface, which will, so from simulator, what will give? We'll get the digital output, and this mapping box, what it will give? Whatever the, whether it could be a ADC or the CAN or the Ethernet, that can be
Interface.
transmitted to the ECU. Clear? Mapping box. And next, FIU.
CAN bus up.
Create
FIU.
fault.
CAN bus of start to battery.
Failure insertion unit.
We can
FIU
insert the
full form
failure.
ఏంటి? FIU full form ఏంటి? Failure
Failure insertion unit.
insertion unit. Okay. So then next, what is the use of FIU? FIU use ఏంటి?
We can create manually failures. Failures we can create manually.
Not manually,
I mean,
automated.
insert the fault of
We can,
faults.
yeah,
We can
yes,
insert the
we can set the ECU. That could be a over voltage, high voltage, or the short to battery, short to ground, everything. And what is a breakout box?
By using jumpers or a banana pins.
Okay, so breakout
Connect.
box is nothing but the connection between the ECU and this setup. We can open and close.
Close. Connect, disconnect.
Yeah, connect and disconnect. Okay, then next, simulated loads, what it is? On top we'll have the simulated loads. What it is?
Motors or lights, sir.
We can check
Sir,
the
can explain BOB once more?
BOB, breakout box. I will show you that. Okay. Yeah, we'll go through this. Mapping box and simulator, fault insertion unit, power supply, UPS, host PC. 1 second. Yeah, I will show you that BOB. See, you know this? What we'll have here with a banana clip. So if you see this breakout box, so these are the breakout box. Okay. So whatever the input we are going to give, we'll short that.
By
Here you
using
can see.
switches.
Here you can see what is there. This is a red is a power supply, and this is a black is the ground. Okay. So and here we can see the light. Okay. With the jumper, Jumper, you know. Okay, with
Yes,
the
sir.
jumper, we'll connect these posts, both actually. I mean, this is a connection we are making. Already I said one example, right? If you are switch on the bulb will glow. Switch off, what will happen? It will go off. Switch off means it's an open circuit. Switch on means closed circuit.
Correct.
Okay, so using the jumpers in the BOB breakout box, we can switch on. I mean, we can close the circuit, we can open the circuit. Clear?
Yes, sir.
Ain't what is a BOB? Can you tell now?
It like a switch, sir, on off switch.
Okay, so on off switch.
Mechanism.
So it's like a open circuit, closed circuit. Clear? So BOB is nothing but a open or closed circuit. Okay, and this will be looks like a. So these are the all the system. This is the main architecture. In architecture, we consist all these things. Okay, and how it look like? So this is the UPS and battery. Okay, so UPS is having a what is that backup? Okay, and this is a programmable power supply. Battery is nothing but okay. We'll get the power supply to ECU and also the load box and also all other components. And next simulator. Simulator what we'll have here we have the LAN cable. Okay, simulator will be having the LAN. LAN, you know what is LAN? Local
Local
Ethernet.
area.
Yeah, internet
Protocols.
connection. Yeah, okay. So simulator what we can do through LAN we can connect to the desktop. Okay, that we'll discuss. And next, so what we'll have here ECU input and output, and next BOB is what breakout box, and next from there will be a mapping box. So what happens? So from the simulator, if I am giving some bulb is, I mean the lamp has to be on BCM, so I will give signal distance signal from here to here. Okay, so mapping box what it will do, it will accordingly whether that is an analog signal or the digital signal, it will give it to the BOB through to the ECU through the BOB. And BOB what we can do here, we can open and close the circuit. Clear? Okay, if I am giving the light on, high beam on, then to the ECU, that signal can be open and close in the BOB. మనం ఓపెన్ కానీ క్లోజ్ కానీ చేసుకోవచ్చు ఇన్ ద బ్రేక్ బాక్స్ లో ఓకేనా సో ఇచ్చాము ఇక్కడ ECU కి ఇచ్చాము we have given the to the ECU. So then from the ECU what happens, so here the mapping box, from the mapping box it will go to the load box again. So from the ECU it will be output, right? From the ECU light on, we have given the signal light on, and from the ECU it goes output as a light on. So that comes from the mapping box and it will switch on the lights here in load box. Clear? Any doubt? And whatever the failures there, right? So here in FIU we can insert, whether it could be a input, could be a short to battery, short to ground, or CAN or anything, bus off, anything, everything we can create in FIU. Clear? This will be having the one LAN cable separately, simulator and FIU. Okay, so we need to operate it individually. Clear? This is clear?
Yes.
Yeah, fine, sir.
Okay, okay. So remaining slides we can discuss tomorrow. So these are the definitions. So whatever the definitions we have already discussed, right? Overview. So those things we can discuss tomorrow. Okay. Just
Sir?
overview.
Sir,
Hello.
for example, for airbag ECU, we will have input buckled, unbuckled, like that. Then these are the simulators.
Yes. So what we'll do in simulator what we do, give unbuckle and will go to the mapping box. Okay, that will goes to the ECU.
And outputs will be as ENS, ECall, fuel cutoff. These are all the simulated loads.
Yeah, I don't know about that, but for airbag, but what I know, whatever the inputs will give, I mean, you can compare with that, whatever the project you have done, right?
These are the simulators. Okay, inputs.
Yes. Simulator from the
Outputs will
simulator.
fill the simulator loads, sir.
Yeah, yes, exactly. Okay.
Similarly, for radar ECU, can we say that simulators will be like elevation angle, deviation, time sensor?
Yes, exactly. So for the radar issue, what are the inputs for the airbag? Simple thing. What will have?
We'll have detections.
See, any issue.
There is disturbance.
Okay, so there is a ECU, right? So it will be having all the inputs and outputs. So these inputs from where we are giving? From the simulator.
Yes.
Of course, this is we can call it as a airbag. Okay, airbag. And next outputs where we are giving? To the load box. We can check those things, load box or the in host system also we can check this outputs. So inputs where we are giving? From where we are giving? Simulator. Clear, airbag, and whatever whether it could be a seat buckled or unbuckled and everything, all inputs will give it to airbag and will get the outputs to the load box or the system in the sense host PC.
Yes, please. Okay.
It's load
Okay.
box means simulate load box, no, sir? Load box means simulator load box.
No. Load box, what I said, lights. There will be lights or something. Output will have. If it is having the lights.
Yeah, simulator load box are also output is come custom. Be simulate motors and glass doors. You said that.
No, don't compare. Don't mix those things. Simulator is
సురేష్ గారు
different. Load box
మీ
different.
వర్షన్ సురేష్ గారు మీ వర్షన్ మీరు కంప్లీట్ చేయండి ఓకేనా సో ఇలాంటి డౌట్స్ ఏమి క్లియర్ చేయకండి
Yeah.
మీ సైడ్ నుంచి క్లియర్ చేసుకోండి టైం అయింది కదా ఆల్రెడీ 1.5 hours
అయిపోయింది టైం సో రేపు విల్ కంటిన్యూ టుమారో రైట్
షూర్
ఓకే యా దెన్
పీడిఎఫ్ అండ్ నోట్స్ షేర్ చేయండి సార్
షేర్ చేస్తాను నేను ఓకే
Sir, how many classes we have remaining?
We planned only 2 classes, so probably we already completed the architecture, right?
Okay, one more is tomorrow, right?
Yeah, tomorrow. So tomorrow we'll discuss the dspace related, and then the sample, how we can write the test cases and all we can discuss. That's it.
Sir, will you discuss that control desk and the automation desk of will setup?
Yeah. Those things we can discuss.
Yeah.
Okay. So tomorrow we can discuss. Just overview. So don't think about. I mean, it will be like from scratch. We don't have any access actually for those control desks. So tomorrow we'll discuss those things. Hello.
Sir, can you sir? Okay, sir.
Okay, then yeah, sure.
Sir,
That's
resume. Can you send resume?
What resume?
Resume, sir.
Hill automation. Yeah. I will be having that, so I will share those things. First, we'll complete this class, then we can. I will share those resumes and everything. Okay.
Sir, today in plant-based, one terminology was there, RLS. So what do it mean?
Sorry, plant.
RLS, something RSL, something was there in example. In plant-based.
That is a rain light sensor.
Okay. Fine.
There will be a rain light sensor will be there. Rain comes, it will switch on the wipers.
Okay.
Sir,
Just concentrate
tomorrow.
on this. No. Just concentrate on architecture. Okay, that you can map with your project. Then
Okay.
after. Okay. Tomorrow same time 8 a.m. Okay.
Okay.
Probably tomorrow will. I mean Prashant will send the link. Okay. Then bye. Okay. Thank you.
Okay, bye.
Deepak, sir.
ఫైన్ థ్యాంక్ యూ అండి థ్యాంక్ యూ సురేష్ గారు హలో, డౌట్స్ ఎక్కువ పెట్టుకోకండి. పెట్టుకుంటే సబ్జెక్ట్ తక్కువ అవుతుంది. అప్పుడు 2 సెషన్సే మనం ప్లాన్ చేసుకునింది సురేష్ గారితో. డౌట్స్ ఇక్కడ చెప్పేది ఏదైనా ఉంటే రిపీట్ చేయమని అడగడమో, దానికి ఏదైనా ఎగ్జాంపుల్ అడగడమో ఇలాంటివి అడగాలండి. అవుట్ ఆఫ్ సిలబస్ తీసుకొచ్చి బయట తీసుకొచ్చి ఇక్కడ ఏం అడగండి. కంపారిజన్ అసలు వద్దండి. సరేనా? ఫైన్ అండి. రేపు కంటిన్యూ చేద్దామండి. సెషన్ సేమ్ 8 o'clockకే ఉంటుంది. ఓకే. సో 1.5 hour మినిమం తీసుకుంటారా? ఓకే.
నాకు కొంచెం పీడిఎఫ్ పంపించరా?
పీడిఎఫ్ వీడియో నేను పంపిస్తానండి ఇప్పుడే. నో ప్రాబ్లం. ఓకేనా? మీ గ్రూప్స్లో నేను షేర్ చేసేస్తాను. ఒకసారి చూడండి, ఇది వీడియో చూసేసి రేపు క్లాస్ జాయిన్ అవ్వండి. ఓకే. నెక్స్ట్ ఈ టూల్ క్లాసెస్ టూల్ వచ్చి మనకి యాక్సెస్ లేదండి. అది పీడిఎఫ్ లోనే చెప్తారు. యాక్చువల్లీ పీపీటీ స్లైడ్స్ చూపించే చెప్తారు టూల్ కూడా. దాని స్క్రీన్ షాట్స్ కానీ ఇలాంటివి యూజ్ చేసి. ఓకే. లేదండి, అది ట్రై చేస్తాము. అది కావట్లేదు. మీరు ఒకసారి ట్రై చేసి చూడండి. అయితే నాకు చెప్పండి మమ్మల్ని.
రావట్లేదని మీకు అడుగుతున్నాము.
రావట్లేదు మా అది డెమో వర్షన్ కూడా లేదు. మొత్తం అది లైసెన్స్ చూపిస్తుంది. అది వాళ్ళు మనకి సేల్ చేయరు కదా, కంపెనీస్ మాత్రమే. అందువల్ల మీకు ఇంటర్వ్యూ అయితే క్లియర్ చేసేయచ్చు, వర్క్ కూడా చేసుకోవచ్చు అండి. ఆయన చెప్పే చాలండి. పీపీటీస్ లో మీకు కంప్లీట్ స్లైడ్స్ మీకు చూపిస్తారు. నో ప్రాబ్లం.
ఓకే. అది ఇంకా టూల్స్ నేమ్స్ కొంచెం క్లియర్ గా చెప్పమండి.
సారీ,
ఆ టూల్స్ ఉంటాయి కదా, కంట్రోల్ డెస్క్, ఆటోమేషన్ డెస్క్, dspace, వాటి వర్షన్స్, నేమ్స్ క్లియర్
చెప్తారండి. చెప్తారు. ఇలాంటివి అడగండి. నో ప్రాబ్లం. ఓకేనా? ఇలాంటి డౌట్స్ ఏమన్నా కూడా అడగండి. బయటకు తీసుకొచ్చి మాత్రం ఇక్కడ వద్దండి. అలాంటి డౌట్స్ ఏది
అందుకే ఏం అడగలేదు.
ఓకేనా? అదర్ ప్రాజెక్ట్స్ కానీ ఏది వద్దండి ఇక్కడ. ఆయన ఏం చెప్తున్నారు అది మాత్రమే విని అందులో డౌట్ ఉంటే మాత్రమే అడగండి. కంపేర్ మాత్రం చేయకండి. వేరే టూల్ తో కంపేర్ చేయడం, అది మాకు చెప్పలేదు మళ్ళీ చెప్పండి అనడం ఏం వద్దు. ఆయన వర్షన్ ఆయన కంప్లీట్ చేశాను నీట్ గా. సరే, ఆయన ఆల్రెడీ స్లోగానే చెప్తున్నారు. ఓకేనా?
కాల్స్ ఏం లేవు సార్ ప్రశాంత్ గారు?
ఈ మంత్ లేదు, నెక్స్ట్ మంత్ నుంచి ఉంటది. ఒక దీపక్ మీతో కాంటాక్ట్ లో ఉంటారండి. ఏమండి, dspace అంటే జాయిన్ అయ్యారు కానీ మాక్ ఇంటర్వ్యూ అంటే ఎంతమంది జాయిన్ అవుతున్నారండి? మీ బ్యాచెస్ లోనే దీపక్ కూడా ఎన్ని మాక్ ఇంటర్వ్యూస్ కండక్ట్ చేస్తుంటారండి? అట్లీస్ట్ ఊరికే ప్రాక్టీస్ పర్పస్ అట్లీస్ట్ 2-3 జాయిన్ అవుతున్నారు. అగైన్ మీకు తీసుకుంటామండి ఇలాగే మాక్ ఇంటర్వ్యూ. ట్రైనరే కూడా తీసుకుంటారు. జాయిన్ అవ్వాలండి అందరూ. ఓకే. నెక్స్ట్ ఈ క్లాస్ అయిన తర్వాత రెజ్యూమ్ కూడా మీకు ఓపెన్ చేసి ఎక్స్ప్లెయిన్ చేస్తారండి. ఇంటర్వ్యూ క్వశ్చన్స్ కూడా చెప్తారు. ఇంటర్వ్యూలో అడిగితే ఏం చెప్పాలి ఈ dspace గురించి అవన్నీ ఎక్స్ప్లెయిన్ చేస్తారు. రెజ్యూమ్ లో మనం ఈ dspace గురించి ఎలా పెట్టుకోవాలంటని మొత్తం ఎక్స్ప్లెయిన్ చేస్తారు. ఈ హిల్ టెస్టింగ్ రిలేటెడ్ మీకు ఇంకొక ప్రాజెక్ట్ కూడా చెప్పిస్తారండి, కావాలంటే ఇంట్రెస్ట్ ఉంది అంటే ఎక్స్ట్రా క్లాస్ తీసుకొని. ఓకే.
చేయించండి.
హిల్ టెస్టింగ్ మ్యాండేటరీ అడుగుతున్నారండి చాలా కంపెనీస్.
హిల్ టెస్టింగ్ ఈ dspace బేస్డ్ ఒక ప్రాజెక్ట్ ఎక్స్ట్రా నేను చెప్పిస్తా. ఈయన సురేష్ గారే చెప్తారు. రేపటితో dspace కంప్లీట్ అయిపోద్ది. హిల్ ప్లస్ dspace కంప్లీట్ అయిపోతుంది. తర్వాత ఎక్స్ట్రా క్లాస్ తీసుకొని హిల్ టెస్టింగ్ సపరేట్ ఒక ప్రాజెక్ట్ మనం సపరేట్ చెప్పుకుందాం. సరేనా? ఫైన్.
దట్ వుడ్ బి
ఓకే.
ఫైన్.
థ్యాంక్ యూ సో మచ్. ఫైన్ అండి. థ్యాంక్ యూ సో మచ్.
ఓకే, థ్యాంక్ యూ.
దీపక్ సార్ ఇప్పుడు వస్తారా?